All right, good morning. So, hope everybody's doing well. Hopefully, all of you turned in homework 4, but I'm missing about 10% of the submissions. So, if you did not turn in homework 4 in a way that lets me download it, I sent you an email this morning through Canvas. Okay, so you should have a note there imploring you to get in touch with me. If you did not get such an email, you can safely assume that I got your homework downloaded and I'll grade it this weekend. I sent you an email through Canvas. Whether that comes to you through Canvas or through an email outside of Canvas depends how you set Canvas up. But Canvas is the only medium through which I have access to email for students because I don't have your email addresses. All right, so any questions, lingering issues that you want to talk about with the stick program, with C, with anything related to anything? Let's see, someone says you have our names, so by extension you know our student email addresses. Well, I know part of your email address is its first initial dot last name, but unless you have a somewhat unique name, there's a number that comes after that. And I don't know how to calculate that number. I think they're somewhat sequential or at least monotonic. But no pattern to that. And you can set up email addresses in CTC Link, but not everybody does that, etc., etc. So as much as I dislike Canvas email, that's the main medium I have to get mail out to students. All right, so one person says they want to learn about how to use VI better. So I want to finish up talking about VI today. And that's you know, it's not something that's going to figure in a large way in your grade, but it's something that I would like people to try to think about using VI and being more comfortable with it and taking better advantage of what VI is all about. Just because it's going to be, you know, an editor that you encounter again and again. And yeah, IDEs are great. Someone who's good with VI is probably at least as efficient as someone who's mediocre with an IDE or possibly even good. All right, and so yeah, good comment in chat, which is you can set Canvas up to deal with mail and notifications however you like. I strongly suggest you set Canvas up to notify you immediately through whatever method you prefer. When there's notifications, changes, announcements, things like that, because I do use that for sometimes timely stuff like you know, if someone discovers a problem with the wording of an assignment, well, I'll usually send an announcement and I'll update the assignment and I'll mark the update to say let students know this has changed. But if you've got digest mode set up so you get a note once a week from Canvas, right, that's not going to do you any good. So yeah, good suggestion. Check out your Canvas email and notification settings. All right. Well, I started looking at some of the stick submissions, and they look good so far, right? This does not surprise me. Like I said, I think people in here are on top of algorithmic issues. I think people understand what they're trying to do and have a pretty good idea how to break problems down into steps that the computer can be told. I'm pretty sure that most of the issues I'm going to see when I grade are going to be around reading inputs and parsing inputs. So there still seems to be some confusion about dealing with command line inputs, argc and argv, And there's nothing more I can say about that, right? I've showed you sample code for how to read an integer, how to tell if you have an integer. There's really not a whole lot else to say about that. I mean, it's done like that, or something close to that, or it doesn't work. For reading input from the user, right, I can't be more plain than to say don't use scanf, but still, you know, 10% of the submissions are using scanf instead of fgets and scanf, so that'll break when I test. And nothing more we can say about that. But those issues are relatively minor, right? My main concern at this point is being able to take a problem, turn it into an algorithm, series of steps that you can tell the computer how to do, and then, you know, being able to do those steps. Input output, always, you know, kind of tricky, and it's going to change from language to language. So that's just something you keep working on. But, you know, looping conditionals, things like that, looks solid from what I saw so far. I just looked at about 20 minutes worth of submissions. So I'm anticipating good grades across the board for homework 4. Homework 5 was a quiz. Homework 6 will probably be your next large programming assignment, and I expect to post that probably next Friday, maybe a little earlier in the week. All right, no questions? For what it's worth, I will mention that some people are still using Chegg. So this was posted in the past week. There's no point in doing this, right? If you can't write the code yourself, eventually it's going to catch up with you. But, you know, what I found interesting about this expert solution is that the expert solution includes the thing you're not supposed to include, which is to kick the user out if they put in the bad number of sticks 2 times in a row. So the expert who, you know, somebody paid to write this solution didn't even write it themselves. They ripped off another solution and modified it. So, I mean, we've got levels of on top of levels of things going on here. At least one person who turned this in did get rid of that piece of the code, so there's a little bit of credit for that. But don't do this, right? This does not help you, right? Your goal is to learn the stuff, to be able to write code. You get in a job interview, they're going to put you in a room with a whiteboard and a marker and say, hey, you know, show me how you would sort a set of integers using a linked list, right? And there you go. You know, and if you can't write integer main, so yeah, and yeah, this is why bridges fall down and things explode and stuff like that. All right, so so don't do that. Save your money. All right, let's talk about VI. Okay, let's go a little deeper into editing goodies. So I'll just play around with a test file here. This is my bash RC. And we talked about the clipboard, right, or what's called the yank buffer in VI. So anytime you delete something, it goes in the yank buffer, and if you say P, it will paste it at that spot. If you say, you know, 5P, it'll paste 5 copies of it, and so on. And you can put things on the buffer by deleting them. So if I come out here and I delete a word, I can put it over here. Or delete a line, I can come up here and put it. But you can also yank with an uppercase Y, so I can just say Y, and that will yank that one line, and then I can put, and it'll put it there. Or I can say 5 yank, and it'll tell me 5 lines were copied, and then I can move wherever I want that to be, and P will paste it. And if you want to paste before the current line, you can do an uppercase P. So uppercase usually goes before. So we talked about that. We also talked about the join command for taking the line below and adding it to the end of the current line, and that's useful. All right, so searching. There's a whole complex search feature available in VI. Mostly what we want to do, we just want to look for a line. So let's say I just want to figure out where my prompt is set up. Well, it's set up in the top there. I don't know much about my bash RC on here. Let's say I want to look for the extract command, right? So I can type a slash and I can put in a pattern, and it will move me to where in the file it finds that word. So extract source code from assess log files. And if I hit the letter N, it will repeat that search. So there's another occurrence of it. And if there's nothing else from that point on down to the bottom of the file, it will wrap around. So if I want to search for all my echoes, there's an echo. Oh, this is a boring bash RC. Let's do my real one. Right, so I can search for alias. There's the word alias, there's an alias, and so on. Right? And if I do a shift N, it will search in the opposite direction, so it will search up instead of down. So normally slash searches down in the file, N will repeat that search, but shift N will reverse it. If I want to search up explicitly, I can do a question mark, and I can do question mark alias, and it will search up, and then in that case a shift N will search down. Those are nuances. They're not going to, like, you know, save your life, but you need to search in your file for stuff. It's a lot easier to do a slash than just move through your code, right? Arrow keying down and looking for what you're looking for. So slash pattern lets you search. And when we get to regular expressions, your searches can actually be regular expressions. So, you know, search for a line that begins with a space. There's a line that begins with a space. So we'll talk about regexes in a few weeks. All right. So the more fun part of VI is using the command line of VI. So, you know, when you want to write your program or you want to exit, you hit a colon and you either say Q or WQ or maybe X or something like that. But there's a whole bunch of stuff you can do at this colon prompt. Okay. There's well, among other things, there's help, right? So you can read all about options in VI. But let's see. So so one thing you can do is you can read the contents of a file into this file. So let's say I have a file called new file. Alright, and I'm editing my bash RC, and I want to include the contents of my new file right here. So I can go out and I can cat that file and I can copy it and come back in and paste it. But I can also say just colon read new file, and it pulls the contents of that in right here. So this can be useful, for example, if you like writing your comment block in the beginning of code in a certain way. You can make one generic comment block, throw it in a file, and then just suck it into whichever file you're writing, and have it appear as part of that file. And it can be anywhere in the system, so I can read /etc/password, and I can read in the password file right here. So you can put in a whole path to it, or you can have just a something in your current directory. But you do need to have access to it. Alright, so I can't read devmem. Alright, so that's cool. If you're looking for a file and you don't know what the file is, right, you can run Unix commands from inside VI. So I can say :!ls and run my ls command. And I can see and I can say, oh yeah, there's the file that I wanted. It was called my file, or whatever I called it. Or :sh to break into a whole subshell. And then when you exit from here, you pop back into VI. You can also, if you're careful about it, you can Control-Z out of VI. And remember, Control-Z does not terminate a program. And so I've warned you not to use Control-Z. We're going to talk about processes in another week. But this throws your job into a suspended state, and you can go back to it with a foreground command. So that's another way to pop out. So you can do commands. You can also read in the output of commands. So I can say written on, read it on, and then I can say read !date, and this !date says run the date command, right, as a Unix command, and the R says read the output of that date command into my file. So there's the date, and I can come up here and I can join that, and now I've got, you know, a timestamp in my comment. Or if I forget who I am, I can say written by, and I can say who am I, and it'll say, oh yeah, you're Nick. Okay, so I can read that in. Someone asked if I'm going to talk about Windows in Vim. I thought about it and I wasn't planning to. It's a feature that I like, and I don't actually remember how to set it up. Oh, that's different from the one I know. Okay, I know the horizontal one. So yeah, you can set up multiple windows. The reason I don't do this is because for me it's just easier to make another terminal session. But it's an option. So :v new. There's a different one that I'm blanking on. It's got a W in it, but it's for, it puts them horizontally. Yeah, Control-W. There we go. So you've got a separate window up here, and you can type in it, you can read a file, you can :vi, and so on and so forth. While we're in here, right, another thing I can do is I can say :vi, and I can put in a different file name. So I can, I don't know, let me find a good file to edit. New file. Okay, so I'm editing my bash RC. I can say :vi new file and switch over to that file. And I can, you know, do whatever I want in there. And then if I want to go back to the previous file, I can do Control-6. I don't know why. Control-6 will swap back, and that'll swap back and forth between my two files. You can also, when you VI, list more than one file on the command line, and I can make my edits in here and then say :n for next and go on to the next file. And then my Control-6 will take me back and forth if I had two files. Alright, yes, vimrc, that's a good one. Alright, let's see, so :vi, :x, :read, cool. Yeah, we can talk about vimrc. So there's ways that you can customize VI. I can say set number, and it'll turn on line numbering for me, right? So that can be handy. I don't know how to turn syntax on, but I know how to turn it off. Anyway, there's commands you can type in VI to change the way that VI looks. You can turn on ignore case so that when you do searches, it ignores uppercase, lowercase differences, and so on. So you can type those commands in every time that you're inside VI, but you can also put them in an initialization script, which will get run automatically when you start VI. And for me, I think it's exrc. Nope. So there's two ways to initialize VI: exrc and vimrc. Okay, they're both hidden files, so they have a period in the front. But you can put whatever commands you want in here, and this can get into its own sort of rabbit hole of features and options and so on and so forth. So I turn my syntax highlighting off, right? And right, but you can turn it on, and then you get color highlighting of syntax and stuff like that. So that's a whole set of options. Something else I was going to say along those lines. And as usual, you can experiment with these inside VI. You can figure out how you want things set up, and then edit your vimrc or exrc file to make it permanent. If it messes up, right, you can always just move that file out of the way, rename it, and then you're back to a default setting. So, so part of what I set up for student accounts is, you know, the hooks you need in VI to make the arrow keys work in insert mode, for example, and so on and so forth. So if you don't set that up and you're in insert mode and you try to use the arrow keys, you get funny stuff like this, right? If you're on a system where that's happening, you need to set up some other options, right, to tell it how to handle those keys and to take them as cursor movements instead of raw input. Let's see, other comments in here. Yeah, okay, so someone had already asked, is there a way to permanently have your lines numbered? So yeah, that's what inspired the comment that it's time to talk about vimrc. So yeah, put that in your vimrc, just set number, or set NU. All right, cool. Let's see, what else can I tell you here? Alright, something I wanted to say about that, but I can't remember what it was. Alright, so command line. So we can also do editing through substitutions. So let's see. Suppose I change my username, and instead of being Nick, my name is Goblin King. Okay, so I can come over here and I can say change word to Goblin King. And, you know, I can come in here and I can do a period to repeat that, and I can search for Nick, and I can do that, and so on and so forth. but that's kind of a pain. So another option is on the command line, I can say colon substitute slash nick slash goblin king. And in that line, it will look for any occurrence of this pattern and it will replace it with this string. And I can do that over a range of lines. And if I want to do that everywhere in my file, I could say 1 comma $, means the last line of the file, substitute nick slash goblin king. And it'll tell me it made 6 substitutions on 6 lines. So global replace, really easy to do. Potentially dangerous, right? If you've ever done global substitution on particularly code, it's usually not that easy. For example, anywhere that the word nick appeared, whether it was in a comment or a path name or something else, would be changed by this, right? So it's kind of a blind faith sort of thing. Right, so the other thing is that substitutions only happen once per line. Goblin King's too hard to type. So let's replace nick with ha-ha. It replaced this nick over here with ha-ha. But not this one and not this one. So I can say substitute nick with ha-ha, and I can say slash g, which means do it globally in the line. Everywhere in the line that you find the string nick, replace it with ha-ha. Alright, so that tells me it did 3 substitutions on one line. And if you want to replace every occurrence of nick everywhere, you can do 1 comma $, substitute nick slash ha-ha slash g, and that does every occurrence of that string. And that's the most global substitute, but probably the most likely to get you into trouble. All right. We can also use this for editing. So let's say that let's say you got numbers on, and I want to get rid of all the stuff from line 29 down to 38. Right? I can say 29 comma 38 delete, and bang, it's gone. If I want to get rid of everything, I can say 1 comma $, delete, and all my lines are gone. All right. All right, and somebody mentioned sed in comments. So, so VI is a visual editor, right? It shows you your code and lets you move around. You can look at a whole screen. That's an update of an older editor, which was called EX. So I can use EX on my bash RC, and I can edit my file like this, right? And EX shows you one line at a time, and you know, visual displays weren't always available. In the 70s, even for a lot of the 80s, the way that you looked at your code was on paper, because CRT screens were expensive and they were kind of finicky, and they weren't as high resolution as you might get with a good you know, a deck writer terminal with a printhead in it. So editing files and things like that had to be done one line at a time. And so you know, this was how you would look at your code and how you would edit, and so on. So VI is the visual version of EX, which is why there's a EXRC configuration file. So sed is a stream editor. Sed basically lets you do things like you could do with EX, but on multiple lines of a file. So I could say sed substitute nick slash haha bash RC, and let's run that through more to see what it does. And this will read in this file, and everywhere it finds Nick, it'll replace it with the string gee ha ha. I need my closing slash. Alright, and there you go. So I can edit my file without having to be interactive, without having to type in commands and move around with my arrow keys or my mouse or something, right? I can hardwire this. And this is really useful in scripting, right? So you want to look at a list of users and change around the first name, last name to be first name, period, last name, or last name, comma, first name, right? You can do all this stuff with things like sed. So end of this quarter, we'll spend some time talking about sed and awk and regular expressions, and this will be all about text processing. And it's a really powerful aspect of working in Linux, or something Linux-like. All right. Again, you know, this is VI. This is what we're talking about. Okay, we're scraping the surface. But I just want to let you know some of the things that are available in this editor, and put them in your brain, and you know, download a VI reference card if you like, and just start playing with some of these things. And guarantee you'll find it makes you more efficient. And it's kind of fun sometimes, sort of trying to figure out how to like look for something or how to do a substitution or things like that. All right, so that's all I had planned to talk about with VI. There's tons more we could say, but that's just kind of putting some stuff out there. Questions, comments about that? All right, so let's change gears again. So let's talk about programming in C. We talked about functions. You know about functions, about how to take your code and not just have one big long main program, but put things into different functions that you can call. They do some calculations, they return values. And you can clean up your main program by having it just call a bunch of functions, and those functions can be mostly calls to other functions. So you can modularize your code, put it into these modules, top-down methodology and so on. But so far, you know, for most of us, all of those functions, the main program, all that stuff sits in one .c file. Okay? As our programs get bigger and more complex, what we're going to want to do is start moving to kind of a different mindset, where we're going to have a main program, some subroutine or function one, some other function or set of functions, some other stuff, right? And our code might be split up over multiple files. And ultimately we want to put these together into a single executable program, maybe just called main. And we've done this a little when we make ODPs. We have a parse function, and then we have a test bed, which is either our main.o or /temp/odp blah blah .o. But let's figure out how to do this in general. Okay, so a very easy way to build an executable from these pieces is just compile everything together. So you could say something like gcc-o main.c sub1.c sub2.c stuff.c. And that works, and that's good enough for first to a first degree, right? This will compile this C code, that C code, that C code, that C code, link all of it together so that when this thing tries to call a function contained in here, it knows how to get to it, right? And if this thing needs to call something inside here, it knows how to do that. So GCC will do all of that linking for us. But we can be much more fine-grained about how we do this. So what we could do is we could compile this with a -C switch. And -C says don't try to build an executable program. Build what's called an object module. This will be a file main.o. And we can do a gcc-c sub1.c and get a sub1.o. And similarly sub2.o and stuff.o. And then these four objects can get linked together into a main program. And how do we do that? We say gcc-o main, but we name the object files. main.o, sub1.o, sub2.o, stuff.o. And yeah, we're definitely going to play around with header files too. That's coming up. So in Unix, you can put a backslash as the last character on a line, and it becomes a continuation mark. And so what I just typed here was ls*.c, but I did it on 2 lines, right? I can make a really long line. It can be, 1,000 characters long, and it'll keep wrapping when I get to the end of my terminal, and that works fine. But when you're writing scripts, sometimes it's nice to be able to break your long line into multiple lines, but have it logically treated as a single line. So you can use this backslash at the end to break a long line into multiple lines. So I'm going to do that here just to make clear that this is all written on 1 line, but I ran out of space on the paper, right? So gcc-o main, and then I'm listing my 4.0 files. GCC will not try to compile my main.c, my sub.c, and so on. I'm giving it 4 already compiled object files, and it's just going to link those together. All right, and the output of that is going to be a main program, which is hopefully executable. The main difference in doing this is that this first way that I crossed out is going back to the raw source code, which could be, thousands of lines of comments and things like that. And it's got to work through all of that and convert it from C into object code. And then it, converts this to object code, this, and then it links those together. Like this, it assumes I've already done that first step of compiling into object code, and it's just doing the linking part. And the big difference is the linking part is relatively cheap. Doesn't usually take a lot of time or resource, whereas compiling C code is very expensive, especially if 90% of your code is comments or documentation or empty space. This is an expensive process. Linking the objects relatively cheap. So imagine you have 50,000 C files being used to build a single executable. Having to recompile 50,000 C programs every time that you change 1 line somewhere, right? That's inefficient. So if I make a change to stuff.c, and this is how I'm building my executable, this is forcing me to recompile those other C files. If I'm doing this and I make a change to stuff.c, I recompile this 1 C file to get a new object, and then I just link my objects. So a lot more efficient. Right? And think in terms of, building the Linux kernel. Right? So if you're writing a stick game, you might have, 4 or 5 functions. You're not going to notice a difference in how long it takes to compile from C files or from object files. But if you were writing a stick game that was, you know, 100,000 times as long, you would definitely notice it. Okay, we're talking about things where it might take, you know, half a day to compile all of the code. So we're going to move towards doing things like this, compiling individual C files into objects and then linking those objects into an executable. Right? Or as someone said, if you're compiling on an old laptop that's really slow, which is definitely a thing. All right, so let's just start playing with some code. All right, so real simple program. Going to call a getNum function, which is going to return an integer. We're going to save that integer as I, and then we're going to call a printNum function, which is going to print that number. So let's write some code, and we'll do this in one file, and then we'll split it up. I'm going to be sloppy here. I'm not going to worry about errors. So I'm just going to prompt the user. I'm going to use fgets. I'm going to read a line of input. I'm going to parse it. I'm going to assume that it's legal input. I'm just going to return that value I. And then our printNum doesn't have to return anything, so I'll make it void. I'll pass it an integer x. And I'll just do a silly print message. All right. So this is fairly pointless code, right? But we're just going to play with it. All right. I'm going to be good and prototype my functions. So getNum returns an integer, and printNum is a void. Did I camel case it? Alright, so it takes an integer and it doesn't return anything. And I messed up my case in a few spots, so I'm just going to change this. So by the way, a tilde will convert between uppercase and lowercase. So I can just hit a tilde and it'll switch that. Or you can just lean on a tilde and convert all your cases. Alright, so okay, enter a number 5. Your number is 5. Exciting, right? Alright, let's see. Yeah, we got 5 minutes. We got time. So let's break this into functions. So I'm going to :write to make a copy of this in something called getNum.c. And I'm going to do :w printNum.c. So :w and vi will write the file out to whatever file name I specify. So now I have 3 files: getNum, main.c, and printNum.c. So I'm going to go in here and I'm going to get rid of all the rest of my files. So dot means your current line. So I'm saying from the current line to the last line, dot comma $, delete. Alright, so here's my main program. I'm going to vi star.c. So here's my getNum. GetNum does not need standard I/O because all it's doing is, oh no, it does need standard I/O. But it does not need a prototype. Alright, so here's my getNum routine. So I'll save that. There's my main that I already fixed. Here's my printNum. PrintNum needs standard I/O. Alright, so now my program is split into three nice constrained pieces. GetNum reads a number from standard in after prompting the user. Main is a really simple file right now, right? It's basically 2 lines. Get a number, print a number. And then printNum is just this silly thing. This is kind of your goal with your main program though. You want it to be ideally pretty short and simple, right? You can think of your main program as just something that like gathers up pieces of other functions and calls them and so on and so forth. It's sort of the main director of the action. But it can be easier to work with this if you don't have, 6 pages of code inside your main program. Let your main program be kind of the 40,000-foot view of what your program is doing, right? In this case, I'm getting a number, I'm printing a number. If I want to do this repeatedly, I'll throw this in a while loop, right? All right, so I can say gcc-o main star.c, link everything together. There's my main program. But let's do this more piecemeal. gcc-c main.c, gcc-c getNum.c, gcc-c printNum.c. And now you can see I've got my original C files, but I've also got these object files, these .os. Right? And these are not human readable. They're made for machine consumption. But now I can say gcc-o main, and I can just link my .o files together and make my executable. Now if I want to change, say, my printNum program and get rid of this number equals and just, print my number out like that, okay, what do I have to recompile? All I have to do is recompile printNum.c and then link my objects together. And now my program is doing this new thing, right? But I never had to recompile main.c or getNum.c. All right, we got 5 seconds left. No, I won't tell you the secret to the universe in 5 seconds. But what we'll start with Monday is these prototypes. We can put those somewhere else also. We can move those out of the way into a .h file and include the .h file just like we include standard io.h. And then our main program is going to be pure simplicity. It's going to be a declaration of main, and it's going to be a couple of function calls. All right. So we'll talk about include files, and all of this is leading up to something called make files. So Monday we'll conclude this, and we'll talk about make files. And make files will make your life really, really happy. All right. So we'll leave it there. I'll see you next time. Thanks.